Example 1, find the equation of the line shown, and what you can see here is this line crosses at certain integer value points, and the integer value points are the ones we want to pick. So right here, like just where the lines cross is where we're looking for, there's a nice friendly little point, 1, 2, 1, 2, 3, 4, 5, 6. You don't have to identify the actual coordinates of points. I'm doing this for purposes of demonstration. All right. The next point I see is right here. Use a different color. Let's call that 1, 2, 3, 2. Continuing along the line here, there's another nice one right there. We're going to call that one 1, 2, 3, 4, -2. Continuing along the line, I get down here to this bottom corner. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 5, -6. All right. All I need is 2 points. Okay, so anytime you look at one of these lines that's graphed for you, there's going to be at least 2 nice pretty points like that to pick. Okay, sometimes more than 2, but in this case there's 4. But all you need is 2. All right, so with that in mind, PJ, pick a point you want to use.
2, 6.
All right, and Austin, pick another point.
3, 2.
All right. So those 2 points will work. It would have worked with any 2 points. We could have picked the blue and the purple, or the red and the blue, whatever, but we're picking those 2. All right, what I want to do is I want to, first of all, anytime it says find the equation of the line, translation is find the slope and the y-intercept. Always find slope first. And slope, when you know points, is found by change in y over change in x. So what I want to do is I want to get from 2, 6 to 3, 2. So from here to here, and I want to first go vertically, and then I want to go horizontally.
Is that funny for you?
Did I make it too big?
I like it.
Yeah, okay. Could have made it bigger or smaller, but okay. All right. So we can see that 1, 2, 3, 4 spaces down, and 1 space to the right gives us our change in y and change in x. Is that too big too? I think that is too big. Anyway, notice that I went from here to here, so directionally I went down, that's a negative direction, then I went right, that was a positive direction. Whenever you're dealing with change in y, change in x, you want to concern yourself with the sign of the number, depending on which direction you're going, to get where you're going. So going down to this level, to the right level, is negative, then going to the right to get the point is positive. So my slope in this case is going to be -4 over +1. Slope is always the rise, which is the change in y, over the run, which is the change in x. Okay? Most people who mess up on these problems mess up right there. They do the slope upside down. Or they don't put the negative sign on the 4. They just say 4 and 1, and they just put 4 and 1. So again, the direction you're going and the value y over x is what we're looking for slope. Obviously, that's the same as -4. Anytime you can make something not look like a fraction, it makes life easier. Okay? If I'm trying to go from the graph to the equation, fractions are not my friend. If I'm trying to go from the equation to the graph, I prefer fractions. Then I got my rise and my run, I can look at it. But if I'm going from graph to equation, integer values are better than fractions if possible. So if this ever reduces, reduce it to lowest terms. And if it comes out to an integer, let it be an integer. All right. Once you know the slope, then we have to go with that along with any one of the 4 points. And we use 2, 6, and 3, 2. It doesn't matter if I use those 2 points. I could use 4, -2 or 5, -6. It doesn't matter which ones you use. Maddie, which one do you want to use?
3, 2.
3, 2. So even though I use 2, 6, and 3, 2, I don't have to use those points. Maddie chose 3, 2, which is a perfectly good choice. I would have used one of these also since everything's positive. These start getting to negatives. Negatives tend to mess people up more than positives do. So that's a good choice for a point. Every equation of a line fits into the model of y equals mx plus b. And y and m and x are all known at that point, so we're trying to find out what b equals. So at this point, it's just a substitution to find b. So 2 equals -4 times 3 plus b. Okay, so that's the structure. These are being multiplied, so make sure when you substitute m and x in, you're multiplying m and x. And then it's just a matter of solving that equation. So 2 equals negative 12 plus b. Move the negative 12 over. That gets me 14 equals b. B is where it crosses the y-axis. Now, looking at this picture, I can see that the thing's going up, right? All right. 14's up here somewhere. Does that seem reasonable?
Yeah.
Okay, let's say one of those mistakes happened. Let's say we call this a positive 4 by accident instead of a negative 4. All of a sudden this is positive 12, move it over, get negative 10, so y-intercept's down here. That should let clue you in, hey, I probably did something wrong. Okay, so look for the reasonableness of your answer when you do it. 14 seems reasonable. That's going up pretty rapidly. Seems like it's probably going to run around 14. That seems pretty good to me. The other thing, upside down, negative 1/4. This would have been negative 3/4. This would have been 2 3/4. That's right there. Obviously, the line's not crossing there. So if you get the wrong slope, you should get the wrong y-intercept. It should be pretty obvious to you the wrong y-intercept. So if you just do a quick verification, does that seem reasonable for this line? Yes, it does. That's probably the right answer. So once I know the slope and the y-intercept, I create this structure, replacing those two numbers with what they are. So the answer is y equals negative 4x plus 14. And that's what we're looking for, the equation of the line that creates that.